We're going to try to finish up at least the circuit design in this video. We might have a sort of follow-up video that goes over specifically the packaging everything up and getting it ready to go off to fab. I don't know. I got to kind of see how time goes, but we're getting a little long here in the videos, as I'm sure you know. I want to start by looking at this design where we left it last time, and I kind of see a change I want to make. So I kind of see this circuit here, which we kind of pieced together. And I was going to put my other circuit in here, but it might kind of start to become a bit of a mess. So I think but it looks like it's going to fit kind of, I could kind of move this sort of into here. So what I think I'm going to do is I think I'm going to bring this down here and sort of work out to do the rest of my circuit, sort of seeing how much space I need. And so I want to show a couple of options for moving things. When you have things routed, I like to route things in little pods. I like to keep it small, a small set of things that are associated with each other, route them together, then connect those associated things. That's the only way I can keep it somewhat neat and tidy. But it often means you have to move chunks of stuff that's connected. And you'll see in some of these videos, I'll break the wires and I'll just click the wires and delete them, or I'll click a part and do unroute part. There's other options though in Altium. And I don't want to go too far into the weeds on the things you can do in Altium because this is sort of an introductory thing. But I wanted to show at least an option here. So if we go to Preferences, and we go to, in the PCB editor preferences, and we go to interactive routing, we can do this component reroute. And component reroute is going to, basically, if we move a component, it's going to try to reroute any connections that were broken by that movement. And there's a couple of different ways that we can, there's a couple of extra settings, and I'm definitely not going to go into all of those, but I just want to show you with component rerouting what happens. So what I'm going to do is, I already know this sharp sensor kind of goes all the way over to here. So looking at the distance here, this sharp sensor is, I think is my 0 here. Well, okay, to make my life easier, I'm going to move the origin of my design to this corner here. So I'm going to go Edit, Origin Set, and I'm just going to set the origin, set my grid a little coarse here. I'm just going to set the origin to here. And then now when I move my mouse, it shows me in this corner my XY. So it looks like this sharp sensor it's over about 1.8 inches. And this circuit here is over about 1.6 inches. So we got about 0.2 inches we can move. We can move this part of the circuit over about 0.2 inches and still be within the sort of scope of this sharp sensor. So I'm going to do that, and I'm going to move it right at this junction. I kind of, this little wiring was already a little tight for my taste. It was already a little, right? We're going to have to solder wires in here, and we got a component really right next to it on each side. So I'm going to choose this, where my battery solders in, as my location to kind of stretch this circuit out. And now that I have component rerouting on, I can select all of these. And if I just move these now, and I think I want to set my grid a little finer. Sometimes what happens is you set your grid to something and it snaps to a slightly different grid snap than you had your other stuff, and so it routes the wires at a weird angle, and so we'll try to avoid that, but we can always undo. We can always save and undo. So now if I move the part, it looks like it's breaking it, right? It looks like it's sort of breaking the connection, and it looks like my grid is a little bit off here, but it's all right for now. So I'm going to move it just kind of to the threshold, or close to the threshold of that sharp sensor right about here. Move this thing back in here. And that looks pretty good. We don't need to push it past that. See, after I'm done with it, you see it reconnects it. So after I unclick that, it just reconnected these traces. So it filled in the gap here. And that's what component rerouting does. When you move it, it does that. We can do it for this one too. If I move this over a little bit to give it some space, watch. Boop, look. So it does a pretty good job. I mean, I don't like to push things right to the limit of their connection distance, so I'll kind of space things out like that. But this did a fairly fine job, I think, of doing that right there. Okay, so if I'm trying to fit this circuit, all of this, into kind of here, geometrically, it's looking like I might want to play some games with these, with this LED here. So let's just try, with that component move on, let's try to move this stuff a little bit. So I'm going to make this one go, I might as well just, yeah, I'm going to move this one like here-ish. And I'm going to change the angle. I'm going to have my LED now just so, I'm just going to keep them kind of, I want to keep the LED next to the edge of the board. And normally you kind of want it sideways. You know what, maybe it'll still work sideways. Let's still do this one sideways. Oops. Yeah, so that one's probably okay where it was. And actually though, if I really want to make some space for this circuit, I'm going to move this resistor down. So I'm going to actually move this resistor like here. Oh, see? And it just rerouted these. And again, for my taste, I don't like to cut it absolutely as close as it has to be, so I'll kind of space these out a little bit more. I'm definitely going to drag this down because I want to leave room up top there, but that's not helping. Yeah, that's probably okay. Actually, I don't like being right next to this. Oops. Oops. Always have undo. Okay. All right. So now that maybe we'll see how it goes. We'll see how it goes now. So now I'll take all of this, select all of this, and now I'll move this whole thing sort of down. Like, it looks like I see a couple things I want to move around. So for right now, I'm actually just going to let this. I'm just going to let this violate the rules for a little bit. No, I'm not. I'm going to put this back. And I'm going to... What am I going to do? I'm going to take this and move it here. Like that. And then I'm going to take everything but the sharp sensor and move it here-ish. Is that okay? Yeah, I think that's okay. All right. So now it's almost a little too good. It's a little too compact in here now. Yeah, okay. Yeah, so, and then I can move the sharp sensor. I do have more circuit to build, so I don't have to fully get rid of all the room here. Well, let's see what happens. So I'll move this sharp sensor, get it right to the edge of the board here. Not right to the edge. Let's do it. Is that going to leave me enough room? Maybe. If not, we can redo it. So, okay. So I just did this. So I had turned on the move feature. It left some stuff that's not exactly what I want. And some of that could have been because I manually, some of that could have been because I had sort of fiddled with the route earlier in ways I probably didn't have to. And there's always little bits you can move around and tweak, and this is probably why my videos take so long, because I just add all this unnecessary stuff. All right, let's leave it like that. Let's not go too crazy here. All right, now this is looking pretty good. Now we still, and I said this before, we had left the power unrouted for all of this, and I'm going to leave it that way for now. But this is looking pretty good. Let's look in 3D view. Yeah, so this is still going to be very easy to assemble. So we still have enough space in here that we're going to do tweezers. We can get soldering irons. Nothing is so compact. It looks a little busy, but this is actually not too bad. This is pretty good. So, okay, let's do the rest of our circuit. So first of all, save all, and go back to. Oops. To my backup approach here. All right, piecing together the rest of the circuit. So what do we have? We have we have our signal. We have our signal from our sharp sensor that is, we have the circuit that generates the excitation for the sharp sensor. We have the circuit that buffers the sharp sensor. Now we have to do our actual sensor configuration that you did in lab 2. So the circuit that I built, I kind of have it over here as a reference here. Now let me go over to this computer. Yeah. Okay. So I'm just gonna. I've talked about this already a little bit, so I'm just gonna assemble it. So if you want to just fast forward through me placing all this stuff down, it'll save you some time. So for those of you who are still watching, the silence kind of gets to me. So I got to think about something to talk about. I don't have anything to talk about. What could I say? What's something people might not know about me? If you want to get to know me, we have time, I suppose. What is there to know about me? Not much, I suppose. I grew up in Alaska. That's about it. Do I have hobbies? No. Do I have special talents? Also no. Huh. This hasn't gone so well. This is not bad. What's something? There's not much to me. This has been very illuminating for me here, I guess. Oh, my thumbs are flexible. Look at that. Right? I know it's gross. Call it hitchhiker's thumb, I guess. Is that a talent? Could be a talent. What type of music do I listen to? Not really. It's kind of varied. Not much there. I actually do listen to a lot of gangster rap. That does surprise people, my music tastes. I like a lot of like some older, you know, Master P, stuff like that. Back when it was real gangster rap. This has not gone well. Oh, I can karaoke Macy Gray. That surprised a lot of people. So I can do. I can. That does surprise people. Where will they go from here? When will they stop? I believe that fate has brought us here. And we shall be together, babe. But we're not. I play it off, but I'm dreaming of you. I keep my cool, but I'm feeling. I try to say goodbye and I joke. Try to walk away and I stumble. Or try to hide it, it's clear. My world crumbles when you are not here. That's what you get for watching the video this far. What are you doing? Don't sue me, Macy Gray or whoever. That perfect, it's gonna get flagged. It's such a perfect rendition. Google's gonna flag it for violating, copyright violation. Okay. So this circuit takes the input from this. Come on. Okay, now let's put in actual values here. So one thing to note, so this is supposed to be just a resistor divider here. So this is just kind of it's supposed to be 10K and 33.3K, but I put a pot in here. It gives us a little bit of an ability to, so I put a 10K pot in here. So I'm going to take 5K from each value. So instead of this being 10K, I'm going to make it 5K. And instead of this being 33.3K, I'm going to make this, shoot, what would that be? 28.3K? And then the top ones, they still have to be 33K. And 10K. And then, so this is my rail splitter. So and again, this is, I want to put a adjustable pot in here to help this out and to give us a little bit of ability to tweak where we split the rail. I don't want this thing to burn too much power, so I'll probably make this a 10K. Make this a 10K, right? So so my circuit design was to have this thing be sort of perfectly split. But this rail splitter is generating a signal, and one thing we can do is, instead of dragging this signal, so this pseudo ground is going to have to be input to both of these. I split my LED drivers into 2 LED drivers. The pseudo ground's going to have to go to both of them, and it wouldn't be that tough to just route it here, but what we can do instead is label. I want to show you how to do net labels. So you can click this net label, and the biggest thing with net labels is you have to actually have the little X here on the wire you're trying to label. Some students, like, they'll do this and they'll put the net label here and they'll think they've labeled it. They haven't. So you have to actually make sure that little X turns blue. In the older versions of Altium, it turns red. But we'll call this pseudo ground. And then the cool thing is, anywhere we take this label, if we just shift click and grab this, and we can put a pseudo ground on these two op amps. So now these signals are connected without us having to drag wires. That's kind of what we did with the port labels. And the difference between this and the port label is nothing. They're both just labeling a signal. The power port labels just have a nice little T that kind of makes it clear it's the top. It's a, you know, it's a supply, and the ground has, you know, little lines to make it look like a ground. But really, we're just naming a net, and that's all that's happening there. Okay, what else has to happen for this? And I could have done that here. Normally, I'd probably label this as like sharp signal or something like that, but I'm not going to. I might, though, space all of this out. So to keep that connection, I'm gonna hold down Control to keep that wire connection. Just move these a little bit. We don't have to crowd this thing. Yeah, let's do this. We got space. Yeah. Okay. So what's happening here? So this is providing gain and offset, but really this is programmed just to be a gain of 1, but an offset of 1.5 volts. So the idea here is, if my signal, experimentally my signal is about 0.5 to 3 volts. If I offset it by 1.5 volts, it's going to be about 2 to 4.5 volts. But the important thing is, I noticed experimentally around 1 volt signal was about where the threshold of like kind of really bad air and good air was. So in this case, that 1 volt signal adding 1.5 volts is going to be at 2.5 volts, which is right dead mid rail. So if we use that as our crossover for LED drivers, it gives us as much headroom from the rail as possible to drive those LEDs, to deal with the forward voltage across the LED. So if I make sure that crossover point is dead smack dab in the middle of my rails, I'm less likely to bump into an issue where my output of my op amp hits a rail and can't actually drive an LED. So, all right, so, well, I got to put the LEDs in. For these ones, I'm going to do through-hole LEDs. So I'm going to do through-hole LEDs here. So this one's going to be if this is going to be the green one. So the green one was if the signal was less than pseudo ground. So if the signal is less than pseudo ground, I think I messed this up. Oh yeah, these should not be grounded. I'll change that. These grounds need to actually be the signal, the offset signal. Yeah. So if these are the offset signal, so if this offset signal is less than pseudo ground, the op amp is going to compensate by driving out. So this LED has to be facing this way. And I should have known that from the design, but I'm just trying to, in my head, rationalize this. And then the red LED should be facing the other way. So the red LED is when this voltage, and let me. So let's do another. Oh man, my mouse is having issues here. So this was our gain and offset signal. So I'm going to add a net label to this and just. I think I messed everything up. I think there's a sleep button on this keyboard that's right next to the. There's a sleep button on this keyboard, and well, it says it's still recording. I accidentally just put the computer to sleep. So, all right, I'm just gonna assume everything went well. So we'll just call this sig offset. So this is the signal that's offset, and then this has to be what actually connects here. And so again, when sig offset is greater than the pseudo ground, that's the case where the air quality is really bad. In that case, the op amp, to correct this larger negative than positive, it's going to pull this low. So that will drive it current through the LED in the right direction for this one. So. And the other thing is I have a smaller range of voltages to illuminate the green LED. So I'm only going to use a 100 ohm resistor because basically the green LED one is, it should basically reach maximum current at only half a volt in my design's case. If you're doing the more normal design, right, they should be the same. But if I'm trying to do a crossover threshold of 1 volt, which corresponds to half a volt over my minimum signal, I only want to do a 100 ohm resistor, so I get 5 milliamps. Whereas this one is 4.5, 2.5, so this is 2 volts of headroom for this one, and it is, so 2 volts, 5 milliamps, so this one should be like 2 volts divided by 5 milliamps, 400 ohms. Okay. Let me stop the video and just make sure it's. Well, I'm glad I checked because it looked like it stopped doing the, when I put the computer to sleep, it stopped doing the screen recording. So if you didn't see that last little bit of what I did, I just wired up the LEDs. I chose a 400 ohm resistor because this green LED is only going to be, it's going to reach maximum current at 100 ohms, or sorry, a maximum current at half a volt off of the pseudo ground. So to get 5 milliamps at a half a volt, we need to have a 100 ohm resistor. And the other one was, the red LED is going to be 2 volts off of the pseudo ground, and so it needs to hit maximum 5 milliamps at 2 volts off, so that's going to be 400 ohm resistor. So that's what happened while you were gone. I don't like that this circuit is so close. Okay. So this looks pretty good. How do I know? I said this is red. I said this is red. This is green. How do I know that? I don't right now. It's not really clearly labeled. So we'll try to be sure to, once this is annotated, we'll try to put a label on the board for which one has to be green and which one has to be red. So it's, physically as far as the board's concerned, it's the same. They have the same footprint. It's just a matter of what we actually connect there. Okay. So let's annotate this. Okay. And then let's cross our fingers and update PCB. So again, we got the nets cannot be matched, and so that happens sometimes, but it's a little unnerving when it does. And usually that's because we played some games with nets, like we copy pasted something and it had a net that was named. It had a net that it had named internally that we had named, or like where we changed the name of, we added the net label to a net that had previously been compiled. So sometimes it doesn't like that. So there's a variety of different things that throw this off, that can cause that nets can't be matched error. So I'm gonna again just Now, again, I always like to assemble this circuit by looking at the schematic. So, and I always like to I like to do these sort of separately. So I'm going to pull pieces in based on the schematic. So let's start over here with this. So R13, R15, and R14. So 13, 14, 15. Oops. So 15, 13, 14. Now what's this big one? This is that potentiometer. So we have 3 different types of potentiometers that you can use. If you look at the components, we have this type of trimmer. It doesn't actually have the knob on there. It just has a little thing you need to use a pot turner with. So there's a little bit, it's not quite as big as the one that I used. We have one that's even smaller, which is, nope. Here we go, this one. So we have 10K. Now these are all 10K. We only, I only got stocked up on 10K adjustable potentiometers just for reasons of just pragmatic reasons. But so we do have these little surface mount ones. One thing to note: the little surface mount ones tend to be they're nice because they're small. You can keep the circuit nice and compact, but they're kind of hard to precisely adjust. It's going to be hard to get a precision adjustment. The potentiometers that I used, the ones that have the big sort of multi-turn knob at the top, those are the most precise, but they're also the biggest, the clunkiest ones. So, you know, choose whatever you want. You know, you can probably any of them will work, you know, close enough to have the project work, but it's kind of a matter of style and convenience. But so if you're trying to keep it slim and trying to have it look like a more modern circuit that just has these surface mount pots, you can use those, or you can use the old-fashioned ones that I used here. But I just wanted to show that those exist. So, but it makes it a little weird if you look at, right? I mean, these are just huge. They're just, you know, towering over all the other. They're almost as tall as the air sensor. So, sort of a big monster. The little resistors next to it just look sad. All right. But what's important is that they're near each other, and they also should be near resistors 11 and 12. Keep doing that. I always want a control tab to go back to the schematic. It doesn't work. Okay, and then our op amp. I mean, it looks like it's U5 is the op amp that we're going to be using, but yeah, U5. All right, so let's just assemble. Let's just try to get this side ready. And looking at the side, you know, I can move this sharp sensor out of the way and give myself some more room, but I kind of want to get this circuit sort of in this portion here. I want to get it kind of, you know, I mean, I'll move this away and give myself more space, but because to get these big adjustable pots in, it's going to take more space than this. Actually, I can move them right now. We'll see how it goes. I'm just showing you I can make space there for my design. I definitely want the LEDs like kind of on an edge somewhere. Okay, so this guy goes here. Let's try to keep these a little compact without getting crazy. Okay, I think that's going to work out just fine for this side of the circuit. And then what was the other side of this op amp being used for? Oh no, 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 no. Oh, no. I didn't want this. I wanted these to be the same op amp. I actually don't know the best way to deal with this. You know what I think I'm going to do to fix this? Just knowing Altium, there's probably a good way to do like some part swapping. So I killed one op amp, and now okay. So now these are the same op amp. Okay, so now we're gonna have to put that other op amp back eventually. But for now, leave it there. Okay, so the other op amp is here, which is the other pot, and 18, 20. So other op amp, 18 and 20, and the pot. That might be kind of an elegant way to do this. We might. It's looking pretty good. I got a good feeling about this. Hey, all right, look at this. I think this is going to be fairly easy to route. Let's try it. Let's try to route this thing. Let's do the low-hanging fruit first. So my grid is clearly 2 cores here. Oops. So for powering this op amp, I'm not too worried about powering or decoupling this op amp because it's getting a strong signal already. It's basically just doing a standard offset. None of this should be really consuming a lot of power. So I'm really not too terribly worried about any of this. So I'm just saying that because, you know, otherwise it might be worthwhile to stuff a capacitor in here right now. what's left unconnected? So sig offset, which is the signal that goes to, it's going to go off to somewhere else here eventually. It looks like it'll be fairly easy to do that. Oh, this. I want to align them a little bit. Okay. All right. So that's kind of my that. Let's clean up these labels a little bit. We'll just pop that right there. Make it impossible to debug this thing. Okay. Does it fit? Nope. Nope, but if I move this up just a little bit, it'll fit. Okay. All right, let's see how that does. Oh, yes. Beautiful. Beautiful. The other thing I found is now we have so much room to work in here. Oops. Might as well move this. So give ourselves some space here. No reason to be crazy about it. I don't know why I'm fiddling with this. I know I'm gonna have to change it here eventually. It's not gonna stay this way forever. All right, how does this look? Yeah. Maybe I could have. I accidentally grabbed this wire, so you can just hit Shift, select, unselect it. Okay. All right, now, oh yeah, we got to put our op amp back here. And actually, selecting things. It's not Altium's strong suit. Really, it's just the... So sometimes if you're having this issue where it's where like I'm trying to move the annotations and it's grabbing the part, so then you just go over to top, just select the top overlay layer, and then it knows, okay, you're trying to mess with top overlay stuff. So sometimes that helps. So I'm just shifting these labels over, and actually it's probably a good time to Go vertical here. Go vertical with the power of do. Okay. We got to put our op amps back. Okay, so not too much for this one, right? This is just our light circuit. But still, we want to assemble this separately. At least I do. Where's this going? Oh, these are the LEDs. Oh, yeah. Nice and symmetrical. So what I might do is I might just delete these LED. So, okay. So which one is LED 2? LED 2 is, this is our green. So maybe what I'll just do, change that to green. And then this one, the K there is the cathode label. The K they have on it. I didn't create these parts, but the, oops, I don't know what, oh, I think it changed it. Did it change the name? Whatever. So that's just an indicator for us. That's just for us to see what's what. All right, how are we looking now? So 3D view, looking pretty good. Is it gonna fit in here? I don't know. Before I start routing this thing, let's just see how we fit. Oh, so close. It's so close to fitting. We don't want to push it too far, too. I don't know why I did this thing so crazy compact. Yes, I do, because it's provocative. Okay. Here's what we'll do. room to spare. With room to spare. How does that look on the 3D view? Yeah, it's okay. It's a little what I don't like about putting components right next to these big ones is if you ever have to reflow these with a hot air gun, it's a pain because you're going to be blowing hot air directly on this plastic pot. There's not really a way around it, but I mean, in general, the problem with these big plastic potentiometers is you can't. It's tough to get in there and do hot air rework. So, but when I build these, I always do the surface mount stuff and then I do the big through hole stuff. So, don't do what I did. Don't do your circuit as compact as this. I don't know why. I don't know why. Yeah, I do know why. But you know, it's a. Don't be inflicted with the same disease that I've got. So don't try to do it this compact. No, that's shoot for excellence. Right? I don't know what I'm doing. Okay. All right. That's fine. That's looking good. Okay. We're all right. So let's just route. Let's route this thing up here. And so I do kind of want to grab. I do want to do a little signal grab here. So I did before we get too far. I don't care about power so much because I can do that later. But let's get the signals we need. I don't like anything about that. Yeah, so let's get the signals we need. So the signal we need here mainly was PS ground. And sig offset. So it looks like sig offsets. Yeah, let's get this thing routed up internally first. Oops, my layer is still on the top overlay layer. So I'm routing internally just because I can. It's always easy to grab signals externally, but if you're able to route internally like this, take advantage of it so that it'll usually make your life a lot easier grabbing signals later on. Sig offset here. I have a feeling I'm going to regret this later, but I can just route this. Like that. And pseudo ground though. I might regret it immediately. Yeah, this is where I'm probably being a little insane with trying to avoid through holes, but I can do this. I can get to it. Don't do what I did. This is bad. This is not good. This is not good design practice. What I did is I just created a giant, now this is a strong driven signal, so it's not that big of a deal, but I just created a giant loop around two LEDs that consume a lot of current, right? So think about this, right? I have these little coil, I have 5 milliamps of current flowing through these LEDs in this loop here. And then I just put a big coil around that loop. So if this were a case where the LED current was like fluctuating back and forth rapidly, I've just created a little inductor. So I've essentially created an inductive loop. So this is not good design practice what I just did. I just wanted to avoid punching through. You know, yeah, why don't I take my own advice and let me just take my own advice here. And sometimes I don't take my own advice because I don't give myself. I've lived with me long enough to know I can't really trust me. So I don't want it. I'm a little wary of my own advice. All right, now how are we going to get to that other side? Yeah, let's just punch through somewhere. So I'm kind of just trying to get away from this stuff before I put a through hole here. I'm going to hit the plus key. It drops that connection. So now I'm routing on the back of the board, and I know I'm probably also going to want to route power and ground. So I don't want to be too crazy with this thing. It's like I'll kind of keep it away from the outer edge of the board, and then you can hit plus again. Drop that connection, hit escape. So now we're connected through there. Okay, so that's a little better, I guess. Is it really? I don't know. Let's move this. Well, I hope everybody's quarter's going well. Okay, do we have any signals left to route? I got 5 volts. I think we do. I think we have to get the signal from this. Yeah. 13.2, what was that? Oh yeah, this one. Yeah, so we gotta route that signal. How am I gonna get there? There's no way I'm getting there on the top of the board. I can tell you that right now. Well, I can get there on the top of the board. I can get there on the top of the board. Okay. All right. Power. Let's route power. So what needs power and ground? So this circuit down here was powered. These two circuits need power though. So and I think we need to connect the power here to here as well. So all of this circuitry needs power. Now this isn't time where I'm just going to look at the bottom layer. I'm just going to resign myself to the fact that power and ground is going to have to go on the bottom layer here. And I have got a nice connection to ground here. So I can run a ground underneath layer 2. I can run a ground connection here. Yeah. So that could work out pretty well. And for the power, I got to get power. I got to run the 5 volts, which starts here, over all around here. So, but I got space here to punch through. So let's start with the ground, and this is where typically we'd have a conversation about ground planes. I don't want to though, so I'm not going to. But let's start with the ground. So I am going to run this so on layer 2. Wrong things here. I always like to go back to this, to the solder connection, the original solder. This is fat enough for a ground connection. I'm feeling pretty good about that. So I'm going to run it through here. This gives us a nice place to pop off. So we can just drop a through hole there, and it'll work out pretty well. Then I kind of, I know it's routed, but we might as well just hook up the grounds like this. Feels good. Now let's take a ground over. We want to be a little careful because I think we're kind of possibly killing our connection here. But yeah, this will be good. And we'll just pop this over here. Okay. Yeah, I think this will be good. So now, so one thing we can do is we can just directly drop these. So we can do place, and then we can hit tab. And sometimes for power, I kind of like to keep them fairly big. So I don't mind keeping them big if it's a power connection. So it gives us better connection. But what we do want to do is we do want to specify the net that is connected to. So we do want to specify this thing's got to be connected to ground. So then we're going to click unpause, make a ground connection here. Okay. And then make place one here. That one's already taken care of. Okay, now we just have to do a little more routing. It's a spindly little connector, but it'll be fine for that. This one we kind of already were pretty close to a ground here, so. 16 something. Doesn't have to be huge. Okay, that one's grounded. Do we have any other grounds that aren't connected? We'll find out later. If we'll run the test to see later. Now we got to get power distributed. So also with power, if there's a convenient way to connect stuff on the top, okay. I don't see it though, so we'll go to the bottom for the power too. So we're gonna get a nice. What we'll start off by doing is getting a nice fat connection here. So. We might have to kind of move that wire here to get. No, we'll be okay getting power here. Okay. And then oops. Run power. This one? That's ugly. I shouldn't have done that. I keep accidentally clicking that dang. Everything that's under there gets. Oops. How many connectors did it have in there? Oh my gosh. I just didn't want it to stick out the end of that chip. Alright, I'm okay with the rest of that. That's fine. Who else needs power? Power here. That's nice. This one's got a through-hole connection here, so that'll be just fine. And can we cheat? No. No, we cannot. So let's go bottom layer. Route. And might as well move this one over like this. Yes, I don't really like this op-amp being powered from up there. So what I'm going to do is I'm going to separately run a power connection to this one. Where do we have to get to? Yeah. Okay. Okay. All right. I think it's done. Wow. So the only rule violations we had were these silk solder mask, silk to silk. It doesn't mean it's right. It means it's not for sure wrong, though. So always keep that in mind. Let's take a look at the 3D view. Sometimes 3D view lets us see stuff. Okay. Let's call it good. So the next video, we're going to polish some stuff up. We're going to do some polishing and packaging. And the next video will have that. And yeah, we're making our way through. Thanks for watching.